I controlled my drone with my eyes.
Move_up. Rotate_left. Move_back.
I made it my mission to bring this drone to its absolute limits. And after creating a hand control, it's time to put the eyes to good use. The goals for control were simple. First, only eyes, nothing else. Second, the safety. Drones should not accidentally crash with something or someone. And third, make it look cool. As always, the code is in the description if you want to try it yourself. So let's get started. First of all, I need a way for my program to find my eyes in the camera frame. For that, I used MediaPipe from last video. Turns out they can also detect eyes. I quickly wrote some code which gets the current camera frame and passes it to the MediaPipe Iris AI model and visualized the results. Next up, I need to detect where I'm looking, which means new task, new AI. After some quick research, I found OpenVINO gaze estimation, which is an open source model that solves exactly this problem. Actually, it's not a single model doing the gaze estimation, but 4 separate models working together. 3 of them are required for extracting the fitting input from the frame. The output from these models is then passed to the actual gaze estimation model. The pipeline I built looks like this. First, I crop my head out of the frame, and then I crop my eyes. After that, I estimate the head pose with one of the models. In the end, I use eye crops and pose estimation as input for the gaze model, which gives me the actual gaze direction. You might be asking, where do I use the landmarks from the first part? Well, you need very precise crops of your eyes for the model to work. Problem was that the eye crops were not precise enough. So the model didn't know what to do with them. That's where I used the iris landmarks to crop more accurate boxes around the eyes. And now it worked fine. Now it's time to implement the commands. These are the commands I want to realize. Implementing the commands is where I struggled the most.
Move_up. Rotate_left. Move_up. Move_left. Move_up. Move_left. Move_up. Move_left.
First up, there were multiple problems. While I'm commanding, I can't look at the screen. So I have no idea what's going on. And it's not safe. So I added a computer speaker to read out the current command.
Hello.
Also, to allow me to look around without triggering commands, I created a locking mechanism. When pressing space, no commands will be detected. Now I want to show you my biggest challenge. And this is where it gets a bit technical. Detecting commands which have a sequence length of 1 is easy. You just have to detect the current frame and classify instantly. But if a command consists of a sequence of detections, it's very difficult to distinguish between single command and sequence. I spent much time figuring out a working approach. First, I tried a queue and timeout approach. Detections would land in a queue, and after a fixed time, a command would be classified. It didn't work that well because sometimes commands were getting cut off.
Move underscore up. Rotate underscore left. Move underscore up. Move underscore left. Move underscore up.
And I was about to call it a day and live with these problems, but I had a final idea. I went with a timeout mechanism. After detection happens, a timer will start. If no new detection happens within a timeout interval, the command is considered as finished and classified. This way, no detections can be cut off and sequences will be classified correctly. It worked quite nice.
Rotate underscore left. Rotate underscore right. Move underscore forward. Move underscore back.
Lastly, to prevent a drone flying away forever if something didn't work, I implemented a watchdog, which cancels a command if it runs for too long. Now that all parts were complete, it was time for testing.
Move underscore up. Rotate underscore right. Move underscore forward. Move underscore back. Move underscore down.
Enough testing. Let's go outside.
Move underscore up. Move underscore up. Move underscore up. Rotate underscore left. Rotate underscore left. Rotate underscore left. Move underscore forward. Move underscore up. Move underscore back. Move underscore left. Move underscore left. Rotate underscore right. Rotate underscore right. Move underscore forward. Move underscore forward.